For topic two, we're going to look at something called the correlation coefficient. We already know that with linear regression, and we are going to specifically talk about just linear regression at this point. We're not looking at any other kind of relationship. But with linear regression, we're going to have these data points that ideally for us are going to fall somewhere near a line. Not exactly necessarily on a line, but near a line. Okay, that's typically what's going to happen with real world data. This correlation coefficient is going to tell us kind of like how compact around a line are these points, okay? So as a definition, we have that the correlation coefficient, denoted by a lowercase r, is a measure that is used to describe the strength and direction of the relationship between variables whose data points lie on or near a line, okay? So we're looking for a number that's going to kind of tell us how strong is this linear relationship, okay? Now, just for some background information about R is going to be somewhere between -1 and +1, okay? Now, the negative and the positive mean something. If R is greater than 0, we are looking at a positive relationship, meaning the slope of the line is positive, okay? So for our values that are positive numbers between 0 and 1, that means there's some kind of positive relationship, meaning that line, if we were to plot it, is going uphill. It has a positive slope. For our values that are less than 0, meaning they're negative, somewhere between 0 and -1, we have a negative relationship. And that just means that the slope is negative. So reading the line from left to right, that line would be going downhill. Okay, so that's what the positive and negative means. Okay, now as far as the strength of the relationship, we have values closer to 0 indicate, well, I don't think I can fit the whole indicate in there, indicate weaker relationships. So values that are close to 0 on either end, positive or negative, would indicate that, hey, there's not like a super strong relationship here. There's points they're kind of around the line maybe, but it's weak, okay? And then we have values closer to 1 or -1 indicate a strong relationship. So the closer you are to 1 or -1, the stronger the relationship is. The closer you are to 0, the weaker the relationship is. If R is positive, that would indicate a positive trend, meaning the slope of the line will be going uphill, it's positive. And R values that are negative would indicate a negative relationship, meaning that like as X gets bigger, Y gets smaller. So you'd have a negative slope, okay? So we have some visuals here, okay? So I've got these 7 graphs, and they kind of show you what are, or well, they show you scatter plots and what the corresponding R could be based on that information. So for graph A, we have this right here. Let me get maybe red. We have points that are slam jam exactly on a line. If your points are exactly on a line, R is going to be exactly 1 or -1. In this case, since the line is going uphill, you can see that R is +1, okay? For this next graph, graph B, the points are clearly not exactly on a line, but they're pretty closely hovering around a line. We could very easily envision a line kind of going through this data set right here, okay? So while the points are not exactly on a line, they're hovering very closely, they're clustered closely around that line, and we have a positive R because the line is going uphill, so R is positive, and R would be approximately 0.8 here, indicating a strong positive correlation, okay? Now, for graph C, you can see there's something going on here. It looks like, generally speaking, as X gets bigger, so does Y, but these points are very loosely clustered around a line. I don't know if that's the right way. They're just not super compact around that line. There's something that seems to be going uphill here again. It looks like, generally speaking, as X gets bigger, so does Y, but the points are much more spread out. Okay, so in this case, R is still positive because there does seem to be some kind of as X gets bigger, Y gets bigger situation going on. But because those points are not nearly as close to the line, they're not nearly as compact around the line, we have an R value here of approximately 0.3. This indicates more of a weak positive correlation. So the way I think of it is an R of 0.5 or more. That would indicate kind of a stronger relationship. Less than 0.5, we're starting to get into that moderate or weak relationship. Okay? For graph D, there is absolutely no correlation here. You couldn't draw a line that hit most of these points if you wanted to. So in this case, R is 0. There is no correlation here. Okay? Now we're going to start looking at the negative side of things. So for graph E, you can see that there seems to be some kind of negative relationship here. Okay? These points are not very closely clustered around a line, but they're definitely sort of linear-ish. It seems as X gets bigger, Y gets smaller, okay? So you could envision a line going through this data set, but that line would definitely be going downhill, okay? There is some kind of negative correlation, but it's a bit weaker. And you can see here that we're saying, hey, R is approximately negative 0.3. The negative being that the line would be going downhill, meaning the slope of the line would be negative, and the 0.3 meaning it's not super strong. We're a little bit closer to 0 here than we are to -1. I need a sip. Hold on. I've talked a lot recently. Okay. For graph F, you can see these points are much more compact around the line. Without a shadow of a doubt, there's something linear happening here. You can see clearly that as X gets bigger, the Y values are getting smaller. There is 100, well, I don't want to say 100%. There is definitely a negative linear trend going on here, and it's pretty strong. So you can see a line that would go through that data. And we would say that in this case, R is approximately negative 0.8. The negative because the line is going downhill, meaning it would have a negative slope. The 0.8 meaning this is a pretty strong correlation. There's definitely something happening here. And then finally, graph G, you can see these points are just flat out on a line. Okay, they fall exactly on a line. And we would say here, because the line is going downhill, meaning this line has a negative slope, we would say that R is -1. There is a perfect negative correlation. Okay, so that is what the correlation coefficient does. It just gives us a number to kind of quantify like how strong is the relationship and is the relationship positive or negative, meaning which direction is this data going? All right, now what I want to do in this example is we're going to use the calculator and, in this case, Desmos to determine the correlation coefficient for each data set. So we're going to start by looking at the calculator, then we will look at Desmos, okay? So I'm going to do both of these. For me in class, I don't care if you use the calculator or if you use Desmos, either one is fine. I'm going to show you both, okay? Because it seems to be that in my classes, it's about 50-50. Half of you prefer the calculator, half of you prefer Desmos. So let's do the calculator first, okay? So here we are. Now, the calculator is not automatically programmed to find the correlation coefficient. So you have to tell it, hey, I need you to start calculating the correlation coefficient. And the good news is you do it once and it'll do it until you clear the memory on your calculator. So this is a one-time thing, but pay close attention on how we do this. What we need to do is go to the catalog of functions. So this calculator has a lot of functions that are just on the buttons. Then it has a lot of like hidden functions. There's a bunch of hidden menus. So we want to just go to the calculator's catalog, okay? So if you look at the 0 button down here, notice it says in blue catalog. So let's go second and then 0 to pull up an alphabetized catalog of all the things this calculator can do, okay? So now we want to go to the D's. You can scroll or you can do second alpha and then choose the matrix button, the X inverse button, or just scroll. I typically just have my students scroll because it's like a 3-button sequence to get it to jump to the D's. So let's scroll. We are looking for diagnostic on, okay? So when you see alphabetized diagnostic on, that's what we're looking for. Getting close. All right, diagnostic on. Make sure you have diagnostic on, not off, on, and then hit enter, and it should say diagnostic on your calculator. You're not quite done though. You want to hit enter again, okay? And when it says diagnostic on and then done, it is set to calculate the correlation coefficient, okay? So let's do this one more time just to make sure. We go second, 0. That pulls up the alphabetized catalog of all the functions this calculator will do. We scroll until we get to diagnostic on. All right, we hit enter, and it's basically saying, are you sure you want me to turn the diagnostic on? Hit enter to say yes, and then it should say done. This is it. You do it one time. You don't have to do it again unless you clear the memory on your calculator. Okay, so now we're done. All right, so what we want to do is input these data sets. So for example, 2, it says, again, use a calculator or Desmos to determine the correlation coefficient. We're going to look at part A. So let's go to stat. Okay. And when you hit the stat button, you have 3 menus that pop up. We're interested in edit, and we're just going to edit a list. So option 1, I'm going to clear out the old junk. At this point, you should know how to clear out a list. All right, so we go over and then highlight L1, L2, whichever list has data in it, hit the clear button, and then just go down. All right, and then it's going to clear out the list. So you want to type in your X's and your Y's in the order from the table, okay? You don't want to like rearrange them, okay? For each X, it has a corresponding Y, okay? So the X values are 1, 6, 4, 3, 7, and 2. And then type in the corresponding Y value. So when X is 1, Y is 2. When X is 6, Y is 5. When X is 4, Y is 3. When X is 3, Y is 3. When X is 7, Y is 4. And finally, when X is 2, Y is 1. Okay? So you've typed in your data set. All right? So double check, make sure your data points look good. I think mine are fine. So we want to hit stat again. All right, and you're going to go over to calc. All right, we're going to calculate something. And this time we want to go to ln reg ax plus b. Okay, it's very important that you choose option 4. Okay, well, I've got my glove on. Hold on. Option 4. Okay, ln reg ax plus b. It's very important that you choose option 4. And then it's just going to say, hey, are your X's in L1? Yep. Are your Y's in L2? Yep. And then just keep hitting enter until it calculates. Don't worry about the other stuff. I'm not going to test you on that. Hit enter. And it's going to do more than you need. But for us, all we're interested right now is the R equals, don't worry about R squared, worry about R equals 0.85. Okay. Now we can also look at the scatter plot. So if we go to the graph, you can kind of see our points here. Let's tweak our window. Let's go 0 to 10 for the X's. And let's go scale by 1. And then let's do 0 to 10 for the Y's, scale by 1. There's our data points. You can see they're pretty closely hovering around a line. And we got R of 0.5. Let me plug my computer in. It's about to die. There we go. Okay. So it seems very reasonable that we would have a positive R value because these data points appear to be going uphill. And it makes sense that it'd be pretty close to positive 1 because these points seem to be pretty closely hovering around a line. Okay. Now let's look at part B. Okay. So on your worksheet, let's go back to, first of all, stat. And we want to edit a list. We're going to clear out L2 and L1. So go up to L2, hit clear, go down, go over to L1, hit clear, and go down. All right. And then for the second list, X's, we have 8, 6, 1, 5, 4, 10, and 3. And then for the corresponding Y's in the proper order, we have 2, 4, 10, 5, 6, 2, and 9. Double check, make sure everything looks good. 8, 2, 6, 4, 1, 10, 5, 5, 4, 6, 10, 2, 3, 9. I think mine looks good. So I'm going to go to stat, over to calc. We're going to choose option 4. Make sure your X is in L1, your Y's are in L2. If you type them into anything else, you want to change your L1 and your L2, but mine are in L1 and L2, so we're good. Keep hitting enter until it calculates. And remember, for now, don't worry about anything except R. In this case, we got R of negative 0.95. Okay, now let's look at the scatter plot to see if that seems reasonable. So I can go, let's check the window here. So we have X's from 1 to 10, Y's from 2 to 10. I'm going to change my Y max to maybe like 15 and my Y min to 15 or my Y max to 15 just because I have an actual data point of 10. So I want to make sure that's fully encompassed. Then I go to graph, and there's our data points. Does it make sense that our R value would be negative? Absolutely. This looks like there would be a line going downhill through these. Does it make sense that it's pretty close to -1? Yeah, these points are very closely hovering around a line. Okay, so that is how you use the calculator to do the correlation coefficient. Remember, you have to turn the diagnostic on just one time. Okay, the only way it'll go away is if you clear out the memory on your calculator. It should be fine otherwise. Okay, so just to be super duper clear, you go second, catalog, and you want diagnostic on. So scroll down until diagnostic on. And then hit enter and then hit enter again. Once it says done, you're good. Okay. And I've shown you this 3 times just in case your calculator gets cleared before you take your final exam. Hopefully you won't have any issues here. Okay. So that's how you use the calculator. Now let's look at Desmos. Okay. Desmos is actually, I think, somewhat easier. All right. We want to, in Desmos, above where you type in your formulas, your equations, and whatever, there's the plus sign. Go to the plus sign and then choose table, and then just type in your X's and your Y's. I'll typically type in all of my X's and then type in my Y's second. So let's see, for X, we have 1, 6, 4, 3, 7, and 2. And then for my Y values, I have 2, 5, 3, 3, 4, 1. All right. And then here's what you have to do. You have to type in something weird, okay? You have to type in Y underscore 1, okay? So Y underscore, to get the underscore, you do shift, and then you do the button that's in between 0 and the plus, okay? So I'll do the underscore 1, so that just gives you the subscript. And then you don't want to type in equals here. You want to use the little tilde button. So you want to go shift and then the button to the left of the 1 on the top of your keyboard. So you go shift and you want, well, there. Now I go shift. So we'll do that little guy. And then we want to do M and then times X subscript 1. So X underscore 1 and then plus B. Okay. And what we're looking for again is R. So you can see here, don't worry about R squared. That's nothing we have to worry about. Just look at R. R is 0.85, and that's exactly what we got on the calculator. Okay? Now let's do the same thing, but we're going to use the second data set. So plus table. Our X's for the second data set are 8, 6, 1, 5, 4, 10, and 3. Oh, let's see. Our Y values are 2, 4, 10, 5, 6, 2, and 9. And then we're going to type in, I shouldn't have deleted that. I should have copied it. Y underscore 1, leave the little subscript, and then type in the weird tilde, which is shift, and then the button that is to the left of the 1 on your regular keyboard. And then we want M, X underscore 1, leave the little subscript, and then go plus B. And you can see that R, again, don't worry about R squared. R is calculated as -0.95, which is exactly what we got on the calculator. So the good thing about Desmos is you don't have to tell it to calculate R, it just sort of does it. But you do have to remember this Y sub 1 little tilde thing, M times X sub 1 plus B. Okay? So if we go back to the worksheet, we had an R value of 0.85 and an R value of -0.95. All right.